Okay, so we get to our extras problem number 2. It says a steel bridge has an initial length of 92.3 meters and its initial temperature is 24.5 Celsius and it is heated to a final temperature of 43.4 Celsius. So perhaps this could have been a very, very hot day. In the morning, the steel started at an average temperature of 24.5 and the sun shone on it all day long and the steel got really hot. And it increased to 43.4 Celsius. Okay, what is the final length of that steel bridge? So it happens to be a long bridge, 92.3 meters. Okay, so the equation that we use is change in length is the coefficient of linear expansion times the initial length times delta t. Right, the amount by which something expands is proportional to how long it is times the change in temperature. And this alpha is a constant. It is measured in units of what? Well, if this is meter and this is meter, the alpha has to be in units of 1 over Celsius. 1 over degree Celsius. It could be 1 over Kelvin too, because a unit change of degree of Celsius is also equal to a unit change of Kelvin. Okay? So the alpha of steel happens to be what? 11 times 10 to the minus 6. Okay, other metals such as, for example, aluminum happens to be 24 times 10 to the minus 6. So it expands more than double the amount of steel. For example, copper happens to be 17 times 10 to the minus 6. So it's kind of between steel and aluminum. Concrete, which is not a metal, but it's just a material also, it also expands, and its expansion is 12 times 10 to the minus 6. Okay? So let's use the steel's alpha. Okay? The initial length is 92.3 meters. The change in temperature, 43.4 minus 24.5. Okay, so we subtract this. 43.4 minus 24.5 multiplied by 92.3 multiplied by 11 times 10 to the power negative 6. So we'll get a change in length is equal to 0.019 meters. Now, how much is that? Well, it's probably better to write it as 1.9 centimeter. 1.9 centimeter is about this wide. So it's actually pretty noticeable. Do you think it's good if you had a little gap there in the bridge between one metal piece and the other? Yes, because otherwise it's going to buckle, right? So you want to have a certain gap so that it leaves room for the metal to expand and contract. So what is the new length of the bridge? The final length is going to be the 92.3 plus how much it expanded? 0.019. Okay, so the final length is going to be 92.319 meters. Okay, which is 92 meters. 31.9 centimeters. So it used to be 92 meters, 30 centimeters, but because it increased by 1.9 centimeter, the final length is 31.9 centimeters. So basically it expanded by about this much. Okay, so that's quite noticeable. Okay, so now you can see how useful this equation is in analyzing expansion of a material. Thank you.